Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 16th, 2025, just yesterday. The big idea is striking. This paper turns self-verification into a simple last token score that comes almost for free, and in tests, the self-verification F1 lands around 80% while boosting reasoning. The paper is titled LaSeR, Reinforcement Learning with Last Token Self-Rewarding, and the implications for model training are quite significant. In short, a lightweight mean-squared error alignment of that last token score with verifier rewards delivers one extra token efficiency, matches large external reward models, and improves inference timescaling via self-reward weighted voting. Also, the authors shared a GitHub repo with everything you need: code for LaSeR and evaluation, example training scripts under VERL, ready-to-run configs and hyperparameters, and release checkpoints for QN2.5-7b, ORZ7b, and OctoThinker 3b. You'll find data pointers, install steps, quick start bash scripts, and an evaluation script for reasoning and self-rewarding. Alright, Figure 1 shows how the method turns self-verification into a last token score and folds it into reinforcement learning with almost no extra work. The key idea is to read the next token distribution at the final token and compute a last token self-rewarding score, which is aligned to the verifier reward through a mean-squared error loss. The left panels depict training that mixes verifier rewards and the learned score. The right panels illustrate test time scoring for solution selection. Well, Figure 1 showed how the last token score is learned. Table 1 reports what that buys in practice. The table shows that LaSeR lifts reasoning accuracy across all three model families, while sharply improving self-verification. On QN2.57b, average accuracy nudges up and the F1 lands around 80%. On OpenReasoner 07b, accuracy stays strong and F1 hovers near 78%. Even the compact OctoThinker 3b sees self-verification around 73%, which signals a reliable last token score without hurting reasoning. So Table 2 compares verification F1 scores for self-rewarding against external reward models across different generators. Verification F1 means a balanced score that judges both catching correct answers and flagging wrong ones, so higher is better. The self-rewarding score often beats the smaller reward models and comes close to the largest one. On the OpenReasoner 0 generator, it leads with about 78. On the compact OctoThinker model, it lands near 74. So, while Table 2 compared reward models, Figure 3 shows how the approach behaves on general reasoning. The left panel reports accuracy on MMLU Pro and GPQA Diamond, with a small lift, for example, about 67% on MMLU Pro. The middle panel shows self-rewarding scores that skew higher for correct solutions. The right panel shows notable overlap between correct and incorrect scores, which signals noisy self-verification. That overlap explains why advantage integration was skipped. Okay. Figure 2 shows that weighting votes by the last token self-reward improves inference timescaling. Majority voting at K means picking the most common answer from K-sampled solutions, while RM at K weights each solution by its self-reward score. The curves with weighting sit above the unweighted ones, because higher confidence answers count more. The top row reports Math 500, and the bottom row covers Olympiad Bench with consistent gains across all three model families. Alright, two takeaways stand out. A single last token self-reward score reliably stands in for verifier reward with almost no extra computation, and aligning it with a simple mean-squared error boosts both reasoning accuracy and self-verification. The broader implication is cheaper, unified training and inference that favor self-evaluating models over bulky reward systems. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.